Good morning, Year 11, it's Miss Bailey here. Please have your worksheet ready to be completing as we go through this video. For your Do Now task, can you recall from last lesson, what does Le Chatelier's principle state? So pause the video whilst you have a go at this. So Le Chatelier's principle states that when we make a disturbance in the conditions, then this causes the equilibrium to shift to oppose the disturbance. And the analogy I used last lesson was that it behaves a bit like a 2-year-old child. When you tell the child to do something, the equilibrium shifts to do the opposite to what you've tried to do. And so we looked at a couple factors last lesson, considering how they affect the position of equilibrium. And we're going to try and do a bit more work on this lesson. But first I'd like us to talk about the balance between yield and rate. So to do that, we need to remind ourselves about what we mean by yield. So this is something that we would have looked at last year when we looked at percentage yields. So yield purely means our amount of desired product. So considering what our reaction, why we're actually doing the reaction, what do we want out of it? So often it will be thinking about it favouring the forwards reaction. So a high yield will mean that our forwards reaction is favoured, as typically that's where our product will be, is from the forwards reaction. Whereas our rate of reaction, we're considering how quickly the reaction happens. And this is important in industry because in order to be profitable, they need the reactions to be happening quickly so they're getting a sufficient amount at a sufficient amount of time. So whenever we talk about yield, we're looking at Le Chatelier's principle and considering the equilibrium aspects. Whereas when we are considering rate, we are considering collision theory. And so those are important to distinguish because whilst something might be favourable to improve our rate of reaction, it may not be favourable to improve our yield because it may not favour that forwards reaction. So today we're going to be looking at the factors which affect equilibrium, so applying Le Chatelier's principle and considering how that affects yield. But you're also going to want to think about, yes, that affects yield, but then thinking back to collision theory, thinking what effect that is going to have on our rate of reaction. So whenever we are changing conditions, these are the thought processes that we should be going through, and the thought processes I was guiding you through last lesson with the card sort. So we think about the change we made. We then think about what is the opposite of the change that we have made. Which of the reactions, the forwards or the backwards reaction, will give that opposition to the change. So once we've identified what the opposite to what we've done is, then we need to work out which of the reactions would give us that opposite. And then our equilibrium is going to shift to favour whichever that reaction is, whether it's the forwards or the backwards reaction. So we'll work through those examples. So with temperature, if we are increasing our temperature, the opposite to that would be to decrease the temperature. And so the reaction that's going to favour that decrease in temperature is going to be the endothermic reaction because that takes in energy from the surroundings and therefore decreases the temperature. And therefore our equilibrium is going to shift to favour, depending on the reaction, forwards or backwards, whichever one is our endothermic reaction. Whereas when we have a decrease in temperature, we've made that change. So the opposite to that change would be an increase in temperature. And so the reaction that would provide that would be the exothermic one, because energy gets released to the surroundings and increases the temperature. And therefore equilibrium is going to shift to favour either the forwards or backwards reaction, depending on the reaction, but whichever one is that exothermic reaction. And those same thought processes can be applied to pressure. So we could consider an increase in pressure. The opposite to that would be a decrease in pressure. And last lesson we talked about how a decrease in pressure would mean a reaction producing fewer moles. Because if we've got fewer molecules, then there are going to be less collisions with each other in the container, and therefore that's going to have a lower pressure. So wherever there are fewer molecules on a particular side of the reaction, that's going to be the reaction that gets favoured. And therefore our equilibrium is going to shift to favour either the forwards or backwards reaction, whichever one goes to the side with fewer molecules. And similarly, with decreasing pressure, if we make that change, the opposite is an increase in pressure. And in order to increase pressure, we're going to be favouring the reaction that produces more moles, because that's going to exert a larger pressure through the collisions with other molecules in the container. And so then our equilibrium is going to shift to favour, depending on the reaction, forwards or backwards reaction, in order to produce more moles. With pressure, I asked you this question. So what if there are equal number of molecules on each side of the equation? So pause the video whilst you have a think about this. Okay, so if we take a generic example, A plus C goes to 2C. So on the left hand side we have 2 molecules, and on the right hand side we have 2 molecules, because we've got 2 lots of the C. So actually there's no overall side where there are more molecules, and therefore in this instance, where there are equal numbers of molecules, pressure will have no effect, because there are equal numbers of molecules on each side, so neither side is going to cause an increase or decrease in pressure. We can also consider changing conditions such as concentration. So we talked about adding substances or removing substances. So if we add something, then we're going to be the equilibrium will look to decrease that substance. And the way it will do that is by using up that substance. So by favouring the reaction that uses up that substance. And so then our equilibrium, depending on the reaction, will shift to either the forwards or the backwards reaction. And similarly, we can look at the opposite way. So if we remove something, the equilibrium will look to increase it, and therefore it will favour the reaction which ends up producing more of the substance. So where the substance is the product in the reaction, and the equilibrium will shift to favour either the forwards or backwards reaction, depending on what the reaction we've been given is. And then the final question, what about catalysts? So pause the video whilst you have a think about what the effect of catalysts will be on equilibrium. Okay, so if we think back a couple of lessons to what catalysts do, they speed up reactions, and the way in which they do this is they lower the activation energy. But when we introduced equilibria, we considered the reaction profile. So if this is our reactants and this is our products, for our reaction between reactants and products, if we use a catalyst, we lower the activation energy. So that dotted line is lower than our solid line. Remember, going from our reactant line to the peak of our curve. So if we're going from our reactants to our products, we can see that we've got a lower activation energy this way. But when we look at the backwards reaction, we can see that actually that has also been lowered compared to our solid line. So our catalysts speed up both reactions equally. So it has an effect on both reactions. So with both our forwards and our backwards reactions being sped up, it has no effect on the position of the equilibrium because both reactions are equally affected. So both reactions get sped up by the same amount as the activation energy has been lowered by the same amount. So you now have a table to fill in on your worksheet, and then once you have completed the worksheet, you have an exam question to be having a go at. Thank you all for watching, and see you next time.